Greetings. Hey, I am. Welcome to a second demo of the game that I'm working on. Here we can view the improvements that exist in the game, should they exist. Actually, I'm going to show a different level than that. Intro to loops. Okay, so here we have a level. We have some new gameplay systems in place. I'm going to move my microphone right here. And we, so the gameplay systems that we have now are pushable blocks that can, I'm going to relocate this, that can be pushed into pits to create a walkable path across the pit. So if this block were not here, we would actually not be able to cross that pit. So it is necessary to actually push this block to be able to progress. So this level is intended to teach the fundamentals of coding in a certain sense. This is for loops. We have different features being added into this product or into our project simultaneously. So we have another system for actually conveying information to the player to let them know what to do or give them tutorial information. This is not really demoing that just yet. Instead, this is just demoing an example level with some explanation of how you might accomplish it. So the final game will actually have more ways of conveying / communicating information to you to learn how to do this, but for now I'm just going to demonstrate it. So yeah, we have a block and we have a goal right here. So we are going to open up a code window just like so, and I'm going to resize this. Actually, we can probably keep it the way it is right now. So yeah, we have user interface improvements coming along as well. So the right now we still have pop-out windows. That's something we're going to fix. So yeah, we have a goal here, a player here, blocks that need to be pushed, and it looks like just a zigzaggy pattern. So as it turns out, we can write a single loop. Yeah, we can write a single loop that gets through this. So we are going to generically write one loop that will do all the work of getting us to the goal. So how we will accomplish that is we will actually define a local variable outside of the loop called up, and have it set default to true. So this is going to be associated with the direction that we're moving at the player. So we'll start with that. Okay, now what we will do is we will first count the number of times that we're going to do this. We're going to go up once, twice, 3 times, 4 times, 5 times, 6, 7. So we're going to loop 7 times. So we'll just say 7. We don't actually care about the number, as it turns out. Do. So in Lua, to write a loop, you would typically do something of this form. This is us specifying a range, so between 1 and 7, inclusive of 7. We're going to loop. And you might bind to a variable in a loop in Lua like this, but we actually don't really care about the binding to something. So we are going to ignore the actual binding to a specific number in the loop. We actually don't care about the number. We mostly just want to do it that n number of times, but less interested in the actual number that we're on. So there might be a way that we could actually, so if we were interested, we could use the modulo operator instead of the up operator, and then we could bind to the number that we're at, and we can use the number that we're at to determine if we should be moving up or down, actually. So that's another approach that we could take. In fact, we'll do that just because it's interesting. So and also we can we'll learn as we go. Sorry, I'm getting some lighting changes in the video there. Okay, so I hope you can see this code. I apologize, we currently still are lacking a feature that allows us to increase the font size. That is something that is being worked on as well. So, in any particular loop, we are going to move up or down a set number of spaces. So we're going to be moving up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces. So we will actually be moving up 13 spaces. So, okay, that seems good to me. And then here we're just going to do some set move. Did I say 13? That seems right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes. 1 to 13 do if mod or I mod 2 is. So this is a way of testing if where we're at in the number, the column that we're at is. So this is my approach to solving this problem, and it might make more sense when you see the complete solution. But basically, we're going to be going up or down a path 7 times. So you'll see that there's like 7 columns that we're moving up and down. So I've just kind of generalized that into a loop here. And if we're on a column with that is the even number column, or actually the odd number column, I'm sorry, I mod 2 is going to be odd, then we're moving up. Otherwise, we're moving down. So that's the basic idea. So if we're moving up, then we go player. We are actually going to push up first and then move up, just like that. Otherwise, we are going to player, push, down, down. So something that we're working on is actually creating a version of a move function that also allows you to, that will have a very similar interface as the push function, so where you'll just pass it a direction. So it would just be move and then you give it a direction, rather than having the function name be the operation that performs. There'll be one generic operation and then a direction you give it, which would make it so that we could actually not have to deal with an if-else case here. And then instead what we could do, if we had that function available, something that we might do is effectively to say I mod 2, and Lua doesn't allow modulo operators, but there's kind of tricky ways that we can kind of get them. The code highlighter is hiding it, but basically we would just pass in the direction to the functions based off of if it were an even or odd number. So that's the idea. And then we would just have one function call, and we would generically change the direction parameter based off of if we're an even odd index. That's it. And this actually just might be about all we need to do mostly, except for at the end of every column, we are also going to move right. So player, we're going to move right 2 spaces. Okay, so looking at this function, first I want to copy this so I don't lose it. And then we're going to look and see what's going on here. So what will happen is I will push up once, and then so we will do a push in a direction and a move, depending on what direction we're going in. We're actually going to push more times than we need, but pushing doesn't have any negative impacts if we don't actually push anything. So it will, if there's nothing to push, that's fine, nothing will happen, and then we'll just move up. So what will happen is we'll push up a bunch, this will fall in there, and then our character will walk here, and then he'll try to push up again, and nothing will happen, and then he'll move up. So not really a problem for us. So I copied and pasted that. So I think we can just watch this function unfold. I think it's going to work. We're doing this 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times. Yeah, this should just take us to the end. And let's just watch it happen. Maybe we won't need to watch all of it, but we can. Falls in there, and we walk over the pit. Move right, and we continue. 1 loop. And God, I don't think I want to watch all of this, but you get the idea. Keep on pushing the block, and the block falls in there, and we continue. Anyway, so I don't think I can execute more code in this editor right now, but I might be able to. Can I create another window? No, just one window. That's fine. I was hoping I could show some other things. Oh, good. We're going to get there. And then this will just take us... Oh, I forgot to put a block there. Yeah, this is unsolvable. That's okay. You saw the demo of the map, so I can go and edit the map to actually make it solvable probably. But you got the general idea. So actually that's good, because now I can actually show you some other stuff before it, because when you reach the goal, it actually exits. Yeah, I need to add a block there. That's funny. Anyway, one nice thing we can do is we can look at the... I can't believe I didn't notice that. We can pull up documentation if we have... This is another new feature we added. So we can look at the documentation for like the player class, for example. So this is going to pull up a lot of information. I'm just going to move it over here so you can see that. I'm going to get this documentation. So this is a new feature that we added, which is, again, I hope you can read this, but this basically returns a list of, gives you information about the class and the available functions for it. So here we have a player that inherits from a type called RPG actor. A player is an actor afforded with more privileges. That's one way to describe it, I guess. And it gets us a list of functions that we have. So here's a function that lets us know how many times we collided with the wall. Here's a function that's a debug function, and it has a... So this property here, it lets you know who it's accessible to. So right, debug functions really aren't accessible to us in play mode. So a grab function, which lets you pick up items. Yeah, so we have a lot of functions here, and this is just one way to get the list of available functions. And it has some additional functionality. It lets you look at the arguments to the function so that you know what you need to pass in. So here is a function called take, and this offers some explanation for it. So take an item from the inventory of any entity found in the specified direction if possible. So you can provide a direction, and then the index of the item to take from the inventory. So this function would typically go hand in hand with a peek function, which actually lets you gives you a representation of the inventory so you know what to take. So you would probably peek first at the inventory of some entity that were near you, and then once you kind of know what you want to take, you would then call take at the appropriate index of the item that you wanted to take. So that's... Yeah, so this is some documentation, some way to kind of get help for the game, because there's a lot of functions and a lot to know, and we're now working on more ways to communicate information to the player to let them know the types of actions that you can take, how to basically information to teach you, and also to let you know what you can do, which is very helpful. So that's been a lot of the work that I've been working on, is just finding ways to make it easy for you to play the game, basically. So I'm going to go up and show you how we actually do the documentation. So here I'm in a class called inventory. So this is the inventory class. And I created this might have been visible at some point in the past, but I'll just show you it for now. There is an annotation that we create called bind, and it includes an attribute called doc. And this is the documentation that gets pulled up ultimately when you call the help function. So this is... Annotations are a compile time... Well, actually they can exist at different points in the life cycle of a Java program, but they're statically... compile time constants typically. So this is something that you'll be able to look at using Java reflection. So when you call the help function, what it's actually doing is looking at the object and then inspecting it using Java code and getting all of this documentation every time you ask for it. Or every time there's an optimization that we will do that will actually lazily initialize it and then store it. But basically what's going on is that we're looking at it and looking at any type that you want to get documentation for and reading it from the Java code using these annotations. And I guess I can show some of the code for that, which would involve, let's look at this, luadoc function. So here we have these, actually I don't even know if I use that. So what happens is that we have a help function that will get the documentation for a type. So yes, for the documentation for the player, for example, it's going to invoke this function here. And this function will, this is what generates like a string template for the nature of the documentation. And it will go through and generate the information. I wrote it functionally if you didn't notice, and then ask for all the methods. And then that will call this doc method function, which is right here. This doc method function will go. So what happens first is that we actually look at all the methods using this Lua reflection library that I wrote. It looks at all the methods, and then it filters out to include only the ones that have documentation, this doc annotation or this bind annotation. So you've seen the bind annotation, but functions that take parameters aren't being bound, so we need some way to provide documentation for the function parameters. So that's what this annotation is for. It's also for the class, so you can also doc the class too. So anyway, so going back to LuaDoc here, we just filter all the methods to only include the ones that we actually care about, which are the ones that have Lua bindings. And then we sort them because we want them to be sorted by name, so it's not just a bunch of random information in any particular order. And then we generate the information about all the methods here, and then we kind of build it all into a single string. So here's where we get all the information about each of the methods after calling get all methods. So doc method to string. We do something functionally very similar where we kind of get the information about the method, typically just the name if the documentation exists. Otherwise, we just kind of assign it none. And then we ask for the documentation from the appropriate annotation. And then we get all the information about the parameters for every method, because every method will have any number of parameters, including none. And then we get all the information about those parameters. And then we get it all as a string. And noticing that I'm actually this is something I might want to fix, but who's responsible for kind of building that string? It changes in these function calls. I might change that. But anyway, so this is the form that it takes, is that we basically go through all the class, all of its methods, and just kind of collect all the information about the method and just kind of like build this long string that we return into the caller of the documentation information. And so a lot of the complexity of this is kind of hidden in a lot of these functional interfaces. And one of them is one that I wrote called get all methods that belongs to Lua reflection. So more code that I wrote. So I wrote all of this, and then this get all methods function I also wrote here. So when we look at it, it involves getting a class and flattening the class, which basically means just taking that class and getting all of the methods out of the class that belong to that class, and also all superclasses and all interfaces. So what this looks like is another functional call, which involves getting all of the classes. So this is another method I wrote that basically goes through and finds all the parent classes and interfaces. And so you can look at that here, and that's what this does. It gets a collection and goes through, gets each of the classes, finds all the interfaces that belongs to that classes, and then adds them to a list, or rather to a set, something that is effectively a set. I could probably actually turn it into a set rather than call this contains method, but whatever. Anyway, so that's what this does. And then after getting all the classes, I then for each of the classes have this function. So going back to flatten class, wherever that may be in Lua reflection, we'll just go back to it. Get all methods, I'm sorry. So we pass in a function called class get declared method. So we can get all methods. So here we're asking for get all methods. We also have get all fields. So I generically wrote a function called flatten class that will flatten it into its methods or its fields based off of what you want. So one function that does both. So here get all methods calls flatten class with this function that gets all of calls flatten class with this function called get declared methods. So it's going to turn a class into all of its methods. And that goes to here, and this is that generically here's that function that returns a member, a function that kind of takes a class and gets all of its members, which can be fields or methods. So we do that. We then map using that function, the class, to all of its members. And then we flat map that into a single collection, which is a higher order function. And then we say sequential, which is our way of ordering it. Which, now that I think about it, I might be double sorting. Maybe. Maybe not. Anyway, so going back to the documentation class, you can kind of see how we use reflection in Java to get this information from about the documentation at runtime. So say we have, let's go to the actor class, which is what we were looking at the documentation for. Boop. You can look at, here we have a lot of doc classes. So here we have the up function, for example, you were seeing. All we do to get to create the documentation, we do it in our code. We don't have this special file that exists out there that we're writing to. It's all with Java annotations, and then it will just, all I need to do to update the documentation is to update this annotation. Moves the player up, and then here we have the up function, and then the parameter, we have an amount to move up, which I document, saying the number of spaces to move. I should probably change this to be, no, that's fine. It can be var args, because if you don't pass it any number, it will just default to something. So that's good. The number of spaces to move, 1 if amount is none. For example, I could write this and it would update the documentation to include that. I could demo that, but I'd rather not. So, and I probably should update them all to actually say that you don't have to include a parameter there. It is an optional parameter. So yeah, this is how that function works, that doc function. So it uses reflection. Like most of what this does involves reflection. Most of getting these the Lua bindings and then inserting them to the Lua environment. That's a whole separate system that I wrote. A lot of code went into this project. I could show a demo of that under proxy, Lua proxy factory. This is where all the magic happens in terms of taking our Java objects and creating the Lua scripting bindings. This get Lua value does most of the grunt work. So here we have a function that says get Lua value. So you give me a type that extends, this T generic type that extends from get Lua facade, which when you look at what that interface is, it is basically an interface that has a lot of default methods and static methods. And that's actually mostly it. Just a bunch of, like, you can inherit, you implement this method and you don't need to do anything else. Or rather, you extend or implement this method and you don't need to and later Java allows the ability to provide default methods and static methods for interfaces, which basically means that, which I should stop saying basically so much. What that means is that you can implement an interface without having to implement anything, which is a funny, weird, bizarre thing. So they might, the language itself probably needs to change how you add on, how you decorate a class of interfaces, because it doesn't really make sense on some level to have an interface that doesn't have anything that you need to implement, yet still have the keyword implements for the interface. It's just kind of stupid. So here's the Lua proxy factory. So this is the function that generates the Lua binding, which a Lua binding is effectively just a Lua type that is invocable. So this creates that Lua type. And the get Lua facade just guarantees, mostly for us, it just guarantees that we have these helper methods for getting useful information, as well as the ability to get the... Actually, it includes a wrapper around invoking the Lua proxy factory, which is funny. Yeah, it's mostly just a helper function for actually getting the Lua value for the type. So you pass in an object that you want the Lua bindings for. Maybe I should increase the font size here. No, that much better. Okay. Hope that's better. pass in the object you want the Lua bindings for, and we represent that object as a Lua table, and we bind into the table the source user data. So we want to attach the object that we're creating the bindings for to the Lua type that we're creating, so that we can kind of refer to it later, and we call it this. And then we kind of call more methods that we kind of inherit from this interface that I created called getLuaFacade. So this interface has a method called getBindableMethods, which is a facade around this static collection of functions. And so we have this interface that we call in an instance that mostly just invokes some static methods that you could also just call without having to use the interface. So it's a convenience interface more than anything. But also necessary for dealing with creating bindings for things that don't have an instance, like the static methods, for example. So here we have the source get its bindable method. So this is a function that goes through, gets all flattens the classes to its methods, like I mentioned earlier, and then filters out the ones that filters them to only include the ones that we have the bind annotation for, and then goes through all of those and sets in this Lua table a key value pair. The key is going to be the function name. The value is going to be this wrapper around an invocation to the Java function that we create, which effectively involves using some more reflection to find out what it actually is that returned that type of stuff, and then creating an anonymous LuaJ data type called the vararg function that will, and here we have some stuff that we need to remove apparently. I'll just leave that out for now. Looking at some security stuff to see if you're allowed to do that type of thing, and then invoking it using some, this needs some spacing here, but effectively what's going on is that we're just creating this wrapper around a call to the function on that instance using Java reflection. There's a lot of work that goes into this because we have to evaluate the signature of the function, the return type, to figure out what we allow, what we disallow. There's probably a cleaner way to handle this that I've looked into more recently that we might re-implement, but this is very functional. Like, we haven't had to modify this since we wrote it, so we don't really have a particularly compelling reason to. It's not really broken, so I'm reluctant to fix it, even though I'm the type of person that does like to fix things and take care of things. This is one of the few things I haven't really wanted to modify since it works reasonably well, and I don't want to break things. But what's going on here is that we're just looking at the function parameters, determining how we're going to invoke the Lua method based off of if you're invoking it using one of two method invocation styles that Lua allows. There's a colon notation and a dot notation for invoking methods that we went over. And then based off of that, as well as the type signature of the method parameters, we will invoke the method one of various ways. That's it, with using the caller. So this is just a wrapper around calling your Java object, but doing it from a function that was inserted into the Lua environment. That's it. So yeah, this is how we do. This is where all the magic happens for the taking Java objects and kind of inserting into the Lua code environment bindings to Lua methods that are able to do things with our Java objects, which is cool. Basically that, and this interface that I made that interacts with. Really, this interface is just a proxy. A facade to some static methods that belong to this Lua reflection class. Boop. And the font size changed here. That's nice. IntelliJ, you're funny. You don't appear to be 12 there. Anyway, so yeah, this is just more walkthroughs of our project. So I demoed the game first, which is the more interesting part, and then you can check out, obviously, for the explanation of the code. But then I walked through the scripting stuff that we kind of demoed and kind of some explanation of it. So yeah, I hope that's interesting. I'll hope to have more a more complete game to show at some point, as well as something that you can actually play. Thank you for watching.